who is the customer, what's the industry. We only care about frameworks. And it doesn't matter if you're Ruby, C#, Python, or JavaScript, or PHP. We are very technical focused. So this talk is about legacy code that is often a result of a framework usage. And I will explain what is legacy, and hopefully it will help. And I will explain what is DDD, and why DDD may help us here, but also what are the pitfalls with DDD. I'm Andrzej Krzywda. I spent some time with different technologies, but now I'm mostly Ruby and Rails focused. But I had some experience with Java and Python as well, and obviously JavaScript because we all have it. But my programming mind is infected by small code for the last 15 years. So I write small code in Ruby, I write small code in Java, and so on and so on. Okay, I run a company specialized in Ruby. I write blogs, books, and I teach about Ruby. But we're going to talk about legacy code. So who of you has some intuitions what is actually legacy code? Any idea? Is it maybe time related? Code that is written. That's extreme. Code that we have to maintain. Yeah?
Not mine.
So I actually predicted quite well. So code written yesterday, so already written, not my code. I also like this one, not my favorite architecture. So if I see nice code but it's not DDD, this is legacy. I'm sorry. So, and we all do it. We are based with our favorite techniques. There are some influences which help us deciding whether it's legacy, and I think the last one, no tests, is like the official definition of legacy code. If a code has no tests, then it's very hard to change, and this is legacy. So how do applications become legacy? How does it happen?
They are getting old.
They are old. But if I write the same code as I wrote 3 years ago, is it a difference? Or is it about remembering what was written, why it was written that way? So here's a book, which is a very classic book about legacy code. It's written by Michael Feathers. If you haven't heard about this book, I really recommend this one. It's interesting that it was published in 2004, which by coincidence was the same year when Rails was released. One of the frameworks which started a huge rise of frameworks in the future. Now we have 2015, everything is framework driven. They are very, very dependent on frameworks. And when Michael wrote that book, there was really, I'm old enough to remember that there wasn't really that many frameworks. In Java there was Struts probably, in some beginnings of Spring. Obviously in .NET world there was ASP.NET already, I think. But it wasn't like this kind of influence that we have right now. Yeah, so this is what is happening nowadays. It's all about frameworks all the time. And obviously, we have a JavaScript framework every day, right? Everyone knows it. No one is capable of following what is the JavaScript framework of the day. There's no such person. Some statistics about the influence of frameworks. I'm from Rails, so we use some Rails examples sometimes. In 2004, there was 20 kilobytes of code. The Rails library. Now, even though the Rails library is still much better, it's 1.5 gigs, which probably tells us something. I think that frameworks, like they took a lot of what we used to do, and they do it for us, which is good. I'm not saying that frameworks are only that, but it says like how the influence has changed. So when Michael was writing this book about legacy code, there was like only 10 pages about framework dependencies. I assume that if he was to write this book again this year, there would be like half of the book about frameworks, and how to escape from the framework. The problem with frameworks is that they are optimized for the first weeks of development. What is the usual time of your project in your company? Anyone worked on a project that lasted 6 months? Yeah, some people, thank you. Anyone worked on a project that lasted 2 years? Yeah, thank you. 5 years? I'm sorry. 10 years. You're wrong. So why are we choosing frameworks which optimize our flow in the first place? But then we have projects that last for years, 10 years. So it brings us joy and speed at the beginning, and at the beginning everything is fine. When we start the first week of development, and we use things like Rails, Django, ASP.NET, Angular, whatever that is, optimized for the quick results. We have a very happy customer, we have a really happy team of developers. Everyone's basically happy and it's like love. And then after some weeks, after some months, there's no longer love. Somehow we have bugs, things are more complicated, the team is no longer so efficient. The frameworks give us what I call the framework sandwich. I'm talking about the backend frameworks. So at the top we get the HTTP request, like in the controllers. At the bottom we have support for talking to the database via some different libraries like Inverse Active Record. I think Django is a similar approach, and the ASP.NET is also has some kind of ORM for that. That's the sandwich of Rails. So frameworks are optimized. Frameworks like Rails, ASP.NET, they're optimized for adding new forms, tables, and columns, which is the thing that we do at the beginning of the project, very often. That's why they're so great at the beginning. They're not so optimized for complex business logic. I'm not saying that they disallow us to handle complex business logic, but we have no support from the framework somehow. And by complex business logic, I mean things like you work on a ticketing platform, buying a ticket, handling a ticket, adding a product if you work on an e-commerce. There are some complex scenarios at later phases. At the beginning, adding a product, you just fill the form, click add, and it goes to the database, and everything's simple. But after some time, you need a lot of notifications, you have several external systems that you need to talk to, and there's a lot to do when you're adding a product to the database. So what are the symptoms of legacy code bases, often influenced by frameworks? We have, by definition, framework-infected code base. We have slow tests. Anyone having a test running more than a minute? More than 10 minutes? More than 1 hour? Those two people here are very experienced. So 1 hour is enough. This is like not the big feedback that we expected to get from tests when we were like buying this idea of having tests. The test setup is long and complicated. Did you ever experience writing this kind of setup for the code? Just run one thing and then assert? This happens quite very often, actually. And we have critical bugs more often. After some weeks, months of development, slower development progress. Also, which is not so strictly technical, we have conflicts in the team. At some point, at the beginning, frameworks give us conventions, and we can use those conventions, we can follow the structure of the framework, and everything is cool because we don't have to argue with our teammates. And that's like, all of the time is safe this way. But at some point, our code base is already bigger than the framework structure. We need to discuss, and there are some conflicts, because some people think we should go DDD, some people think we should go chaotic way, and we have some arguments. Infinite API, this is interesting mostly from the dynamic language perspective. I'm not sure if C# has the same problem. But with things like active record in Rails, and probably there is something similar for Django, we have lots of dynamically generated methods, which means that our model like active record models, they have like infinite API. You can call them in many different ways. So you have no idea what's exactly the way we will call this application. So domain-driven design aims to help with complex business logic. From what I know, it's very popular in the .NET world, it's popular in Java world. It's very interesting that it's popular in the PHP world, which people often make fun of. It's not very popular in the root world, it's not very popular in Python, as far as I know. So why it's work better than DDD? It's good to have some new techniques, so even if it's just learning some new vocabulary for faster programmers, it's a useful thing. But I think the most important part is that we can, like, this conference is great because we're sitting here, C# developers, Ruby developers, Python developers. We think we can talk to each other, but very often we have like no shared vocabulary. If I talk to you about active record details, because I'm a web-based person, you would understand me if you're a C# person, right? So that makes it difficult. So DDD is a way of giving us some high-level patterns so that we can actually talk to each other. There is this idea that we should go microservices with our systems. This talk is not about microservices, but DDD is this nice side effect that it prepares you to go microservices if you do it well. How to start with DDD? There are several patterns. I'm not going to describe all of them. If you never did DDD, service object is a nice gateway drug. Because all it basically means is that take your controller code and put it in a new class. That's it. So technically, it's not a huge difference, and we didn't really achieve that much. But mentally, it's a nice thing because you suddenly have this idea that you can separate from the framework. And that's like the first step. When we talk about DDD, there's often this separation between strategic and tactical DDD. How many of you actually already know DDD, something about DDD? Okay? So very often we start talking about practical DDD, which is actually the less important ones, but you probably heard about those patterns, right? Even if you don't know DDD, you probably heard about the ideas of entities, value objects, aggregates, domain events, services, and so on. You don't have to do DDD to use some of those techniques, so they're quite popular. This is the flow, actually how to do that. But I described the Rails request lifecycle. So how it looks like if you go from the web through controller and through a service object, you give the form to the service object, and you have repo, which is an active record, and that's the way the flow can work, more or less. So the details are not so important here. The idea is that we have application services at the top of our application. This is the part that is called from the frameworks, from the controllers, for example. And then you have an aggregate, which is loaded to the repository. Basically, it's about normal object-oriented programming. So you have an object that you retrieve from the database, you do something with it, and then it persists to the database. I'm not focusing so much on the details because the point of my talk is that those techniques are not so important. Often, what we see in our application, and that's an important reflection I think at some point, is that we think in HTTP requests because we work on web applications, right? And often we try to handle things like update customer within one part of code. While if you have this long form for the customer, you have several things that can be changed. And because our application is used from the web perspective, all of our application code is already infected by this thinking that we receive some data from the web form, and it's this batch of data, so we need to handle all of it in like one place. But often it's several different, like we would call it domain calls or things we can do with the domain, like move to new address, change email, or introduce new contact person. In one of our projects, we had one request being split into 15 domain calls. So what was previously handled in one place because we were like so infected or someone before us was so infected with this framework thinking, is that it was handled in one place, but then we could easily wrap it and find 15 new classes. And it's not about having several new classes and that's cool. It's about being able to easily cope with the complexity that happens. So if we have 15 domain calls, which was for adding an event to the ticketing platform or updating the event, then there are several different important things that we can handle. There is an important distinction between application and domain, and this is a thing that often we use when we go frameworks. As Uncle Bob defines it, application layer is the thing that is very specific to the way the application is used. So like in the web application, the fact that we have HTTP requests and it's stored in the relational database, this is application code, this is the infrastructure. while the thing in the middle, if we're working on e-commerce, adding product, selling product, this is like the part of the domain. We could even imagine reusing this code in a mobile application, even though it's no longer used by HTTP request, and no longer has a relational database under the hood. So the domain code is the code that could be reused in other applications that are produced in a similar way. And strategically, DDD is the part that is, I think, most valuable in DDD. And it's basically about drawing diagrams we don't like. But I will try. This is a diagram from Martin Fowler. The colors are obviously broken. So there's this idea that on the left side we have one context for our application, on the right side we have another context. Let's say it's an e-commerce application. On the left side we have sales context. So we deal with things like products. The product with customer, with pipelines, so there's like all sales things. And on the right side we have like the customers can submit tickets, we can talk to them, talk about defects, what kind of product version they have, and so on. So this is like two applications. And when we see it already separated, it sounds clear, like, because those are two applications, right? Two modules, they are separated. But when you look at all the code bases of what we usually produce, it's basically one monolithic thing. So there's like association that we can go from opportunities through territory to customer, and then you are on the support context, and you can call the ticket, for example. So you can through the associations, you can go directly to other places. And the idea with bounded context is to keep those things totally separate. They have their own persistence. They don't see each other's tables. They don't look at each other's tables. And the idea is that they can even be developed separately. The customer and product here, they're like shared in those two places. The identity stays the same, you could say. But it's that there are different things in different worlds. That's why it's important to keep them separated. Yeah, I found this quote just recently: when something is wrong, something is not good. And this is the idea basically of the idea about the context. So try to find smaller pieces. And this is something that we were taught at universities. Like this one probably for many of you, like divide and conquer. We should write programs that consist of smaller programs. But then we go to web applications, and somehow this rule doesn't apply to web applications. We keep everything in one place, and it's like one flow usually. Let's imagine a tool to manage a software house. So we can automate the work of a company which has customers, developers, and handles some projects. We could imagine 5 different bounded contexts here: human resources for signing contracts with developers, for example. You can imagine project management, how the people are assigned to the project, if there's any rules for that, maybe a history of that. There is the finances business bound context, so one module for that. Communication and invoicing. So invoicing is something that could be easily outsourced. There are so many like software as a service things that we can say generate an invoice for me. It's not, this bounded context is not interesting from a software house perspective. This is not like a business advantage that will generate nicer invoices, right? That's not at all. And I put the lines in those parts which I find, for example, in my company more interesting, like handling the projects and handling finances. And this is where I put layers. Layers by, I mean, those repositories, adapters, and things like that. So to create some bigger design, bigger architecture in those places, because those are the complex ones. However, if we already have this split, the complexity reduces. It's easy to imagine project management if I don't have to deal with the fact whether the developer is already in the company or not, because of the human resources part. So from the project management perspective, all it's interested in is to receive at some point a notification, event maybe, that a new developer is in the company. So from the project management context perspective, this is the important part. Those things are optional microservices. In the future, they don't need to be, but they should be. We can imagine that they could be partially available. So if we have human resources, microservices going down, the project management part should still work because it has still all the data we need. And this is what we get when we go microservices here. Again, I will repeat, those things could use different persistence mechanisms. However, it's about conceptual difference. So we can use the same Postgres database or MySQL database, just important that we don't look at each other tables. Everyone has the same tables. There's probably some decodification here. Some other context we know about the idea of developer or a customer, but that's okay. Those are important concepts. They need to be duplicated. Yeah, and DDD and microservices is like if we go one context, this is like also from the scale and efficiency perspective. Like in microservices, we try to avoid querying from one service to another because it's expensive. So when we go one context, we already have this like almost optimized for the network number of connections. So there's like reduced number of connections at the cost of duplicating some data. Okay, so how to get there from legacy? So we started with this idea of having frameworks which are causing our code base to look not very cool, and now we have this idea of having DDD. So the first thing is actually, this sounds basic, sounds like an elementary thing, but I met many teams which have no idea, no shared idea, like what are the modules, what are the bounded contexts in our application. Like, I talked to one developer and they told me like, yes, we should have this invoicing module at some point because like this is like a totally separated part. But then I talked to another developer from the same team, they have no idea about the invoicing thing. They both work at similar code and they have different understanding of what is conceptual here, even if it's not really there as a module. And this is a potential problem. So I would start by sitting with the team and agreeing like what are the things that we need to separate sooner or later, or even that we can understand that those modules exist. And that was the important part. I've seen some teams, and I'm also guilty of that, where I suggested going DDD light in places where it wasn't really needed. In places where crap was super okay. And we went with repositories, adapters, and the whole complexity that goes with that. So this is the important part. And this is the part that I showed you in this software house diagram. That from my perspective, as this kind of company owner, like the project management and finances is something that would actually benefit from having some complex layers. But other parts, invoices, contracts, it's just create update really. There's no logic behind that. Some example bounded context, because I know that people have problems with like, understanding what is really this idea. So this is, let's say this is an e-commerce application or a ticketing platform. We have total inventory. The idea that there's something to be bought, but it's not really interesting from the inventory perspective what's the price of that. It's only interesting like how many items are still available. So inventory module handles this kind of thing. Then we have invoicing. And again, it's not really interesting from the invoicing perspective of what's the current state of the inventory. It only cares what needs to be printed and sent to the customer. That's all. Ordering, that's another part, like what is basically available right now and how the customer can buy it. Finances, we don't care about inventory here, we only care about the dollars and how much money was spent. And let's say there was a forum e-commerce thing, it's like another separate thing, probably worth outsourcing a different tool or different service. So going in this direction is an ongoing process. There's no such thing as going for 2 months rewrite. Anyone ever had this big from your customer where it was like, yeah, you have 2 months now to go refactor whatever you want. Doesn't happen. Oh, someone there. I want to talk to you. Yeah, so this is rarely happens because we are it's expensive. It's something if we are paid, but there's no visible effect, like in the form of new things on the UI or some new features in the admin panel. Then someone has to justify what happened with the money. And justifying it with, we now have this nicer structure inside. This is not a good justification. It needs to be like better quantifiable. Next, peopleware. The biggest potential blocker for growing DD or whatever, like better structures, if you in your team one person wants to go with some changes, and some other people are not against, but are not fully convinced that this is worth it. Anyone has this problem in the team? There are some people that this is difficult because we are still at the same level. We are teammates. We can't say we should go this way because I say so. We need to find better arguments. And this is like the biggest problem. So if you don't convince your teammates, don't even go this way because they will sabotage your ideas. In the end, the project may fail because of that. Huge part of going to DDD is to use a better language, and we should refactor it. We should escape from the crowd words, and we should learn the main language. And we should watch the business people in their natural environment when they talk to each other. Because it's interesting, the business people, they behave differently when they're close to developers. They're like becoming stupid. They're using this crowd class. They don't say the things that they would normally use when they talk to the boss or to other set people. They use words like, can you add this feature which lets me update this row? Or can you add this feature of creating this record to the database? And this is like completely the other direction that it was supposed to be. We were supposed to learn the business language, but what happens in practice, and I've seen that in many projects, also our projects, is that the customers, the business people, they learned to speak cross to us because they know that we understand this language. While explaining what is margin, profit, and some procents and dollars and so on, this is difficult for us developers. We usually prefer not to think about money. So when they talked about the business perspective, which is always about money, then we are becoming blind and we are no longer available to have this conversation. So what are the ways of learning the domain language? Try to watch the business people in the environments where there are not developers, basically. That's the trick. So go to the customer support, try to listen to what they are talking about. Maybe read some books or blogs from the industry you're working on. If you work on an e-commerce which sells furniture, you need to understand what is in the furniture business going on. Like what's the usual production line? Where is this furniture produced? How long does it take to get to the customer? What are the problems in this industry? But they're not so much related to technical parts. You like feel this thing. There's this idea of inner storage which we once tried, and I think it's interesting. You bring some people to the room, and we put notes on the wall, and the notes represent events that are happening in the system. And it's actually interesting because it seems to be that business people are good at thinking and speaking about domain events, which is the idea from the DDD, which is very useful and like a huge part of the DDD. Customers and business people are very good at showing the time-oriented flow. What they are not so good at, from my experience, is the thing that we are usually good at. We like to think about data structures. Like, okay, so product has a name, has a price, has some kind of availability, amount that is available. This is not really the language that customers use. For them, everything is from different worlds. So if you talk to the salespeople, they're not so interested about the description of product. Maybe I'm just guessing now, but in some parts they're not guessing it, that they're not really getting it right. But they are very good at saying this is the time-oriented flow. If we add product, someone sells the product, someone gets the product, this is what is happening. Frameworks bring us this idea of conventional configuration. I think it's thanks to Rails or due to Rails, which is like write some code, and due to some magic or hidden configuration, it will work. And this is a thing that is usually blocking us in refactoring to a good thing, because they're so depending on the framework conventions. Okay, quick thing about test coverage. If we try to refactor the code and go in bundle context, it's like something very difficult. We need to do it in small steps, but also we can't break the code. The regression that can happen is something that is like, I think, the biggest problem in our industry. We don't really realize that. When we go to a mechanic and we want to fix brakes, and they fix the brakes but they break the windows, we are surprised and we are sad, we are disappointed. But in our industry, when they ask us to fix one part in the admin panel, and somehow we manage to break the flow in the customer buying the tickets or buying the products, we say, well, it happens. It was the other developers who left this code broken. It's not my fault that it happens. And this is something that is happening to us very often. We almost take it as something normal, but it's not something that we should accept, I think. We should aim to change code without breaking it. By the way, line coverage, which probably many of us use, is a joke. It doesn't really tell us anything about whether we are safe with changing. Mutation testing, if you haven't heard about it, please Google it or please find the tools in your language. The sad news is that when I Googled it, it's apparently there's a good tool for Java, a good tool for Ruby, and for Python, C# and JavaScript there are mostly prototypes for that. The idea is that the mutation testing takes your code, parses it, creates the abstract syntax tree, it changes some nodes in the abstract syntax tree, it tries to run your tests, it expects that your test should fail because it's now a different code, it's a mutant now. So this idea you can apply manually. If you change one place in your code from true to false and then you run tests and it doesn't fail, it means that you have backup coverage. So any refactoring here is dangerous. Another thing, if you are testing, this is a habit I think in all the programming communities. Like we tend to test every class in isolation, or even in Ruby, I know there's a popular approach to even test all methods in isolation, which is a thing that creates us some confidence for refactoring possibly, but also it means that whenever we want to change the structure of the code, we need to change all the tests. So this is like cementing our design, it's not helping us that much. So escape from the framework as soon as possible, like the idea of service objects being called from the controller. Don't just pass the params and hash everywhere, this is the Ruby thing, but I know that in ASP.NET also this request object. So in the application controller, you should receive things that are in your domain only. So don't use the framework details later in other layers. If you have some legacy bundled context, because not all things work refactoring at the same time, you can wrap it with application service. That way you can define what's the API, like what are the ways to call it. And use events to communicate between bundled context. The idea is super simple, and you can just get whatever is in your technology helping you with publishing events and handling them. In Rails, as a company, we release a very simple tool for that, which helps dealing with events. So events are a good starting point, I would say. Like, you can always publish an event and never subscribe to it. Even as the first step, this is like a nice refactoring step. You already have some facts being published and informed. Many people go async when they go microservices or DDD. So if you go microservices, you have to rely on the network, so you're never sure if the thing is actually working, so you're async already. And I think that it's better to refactor to bundled context and keep the things in sync, so everything is happening inside one database transaction. That's why I say it's a different restriction, but it could be part of the same database because you have many benefits there. You should try to eliminate query from one bundled context to another. So always publish information so other bundled contexts can know this information to avoid situation that we need to query. The project management needs to query HR, human resources, to know what's the list of developers. It's something we could do, but this is like unnecessary dependency. You can persist with the list of developers on your own site. And then you have to keep everything in sync by publishing events like the developer left the company, so the project management part now shouldn't know about this developer anymore. It's much easier to test if you have no dependencies, but it's only everything is pushed to you, so there's like one direction of data. And you can also go read models, which is like a useful thing if you have a complex view on your website somewhere. So don't query different things and then join them. Try to keep one data structure that is generated on the write time, not on the read time. There's this idea of that once you have those events being published, as I said, you can even publish events and not do anything with that. But then you can go with event sourcing, events become all of your information about the data. You can basically apply all the events from the beginning of the project to some point, and you can hear the state that you should have at this point in time, which is a very useful thing to do. And by the way, I know many people are trying to learn Haskell, Clojure, F#, functional programming languages, which is a cool thing. And DDD is a nice way of going functional programming to your kind of project. Events are those immutable data structures. They don't change. This is the thing from functional programming. Event sourcing is basically default. So you take all the events, you apply them, so you reduce them, and then you create the state. The state is always a result of calculation. It's not a state like the state that functional programming people hate, right? So there's no mutations once you have events. Distributed transactions are tricky, so once again, a reminder, don't go microservices if you don't know how to deal with the problem that things are happening in different nodes and you have to deal with that. There's no transaction anymore. And simulated transaction is like not the best way to go. And also when you have your project split into smaller complex and someone submits a bug and you're running these like dozens of projects that are in maintenance, it's much easier to set up one project and fix the bug than to set up a thing that is a monolithic block of everything in one place. Okay, so those were the suggestions and recommendations for legacy code bases. But often people ask me like, okay, so how should we start? Let's say we know we screwed up the previous project, there's no hope. How can we do it better the next time? How can we prepare for DDD maybe or whatever is the way? And often I talk about the different wrong parts of the framework, but I don't mean that you shouldn't go framework. Frameworks are best, as I said, they're optimized for the first weeks of development. So the idea here is that you can go, you should go with the framework at the beginning. What does it mean at the beginning? I say it's somewhere 2-3 weeks. It's a number from nowhere, but you can say it's 5-6 weeks, whatever works for you. But it's probably not 5-6 months. This is already too late, and then we have much bigger problems to deal with, to escape from the framework and to create random templates. So the idea is that starting the framework, within the 2-3 weeks we have a really nice prototype. But as Tomasz said, we are in this industry where prototypes go into production. This is like the obvious thing. So we need to deal with that. So the next step is like we shouldn't ask for a 2-month rewrite now. We should basically know where we're going, like know what are the modules to separate. We should know about down events and so on. And this is the moment where we can separate and gradually refactor, gradually add test coverage, gradually do much better things. At the end, after like, I don't know, 6 months, 1 year, a framework is a detail. It's almost like it doesn't need to exist in your application. I was talking about some abstract ideas. If you want to see real code examples of good DDD, there is Ponder Known, a guy who wrote Implementing DDD, the best book in this topic. And he has a publicly open repository of DDD samples. So this is an application which, as you can see in the root directory, you have some Edge APM, collaboration, identity and access. So those are under context, and they're clearly visible at the top of your project. So you can go there and like see what are exactly the application services, what is the domain, like what are the aggregates, and it's much easier to. It's in Java, I'm sorry. For many of you it's like offensive, but it's similar to our languages. It's okay. I recommend reading the Implementing DDD book, like by the one well-known. But there are some other books if you are into reading books, like the classic is Eric Evans, domain during design, he introduced the concept. And if you want to improve your refactoring skills and be safer with that, you should probably read Martin Fowler's Refactoring, and you should be working effectively with legacy code by Michael Fevers. And with that, we can summarize with those simple points. Be aware of the fact that frameworks have at the beginning but then lead you to legacy. Be aware that not all mounted contexts need to be like super complex with repositories and abstractions. Cross are okay sometimes. Domain events give you a lot of value, and improving your refactoring skills will help you to get to the point where you want to be, where you no longer hate your current project. And with that, I wish you happy refactoring, and thank you.
What is the difference between a DDD and DDD Lite? Because I never saw this concept.
So DDD is strategic DDD and tactic DDD, and tactic DDD is a DDD Lite. Like it's like the same name. So it's about those patterns, like application services, repositories, and so on. That's it.
Thank you. Any more questions?
I will be here in the evening for a beer, so you can always grab me there.
Okay, so thank you very much.
Thank you very much.